in the OSI model, when it was proposed, there was the 7-layer physical data link, network, transport, session, presentation, and application. But talking about this model, it was into the history, means it was proposed model, and session layer and presentation layer was not giving us the functionality. Also, data link layer was not as much powerful. So these layers are merged together and the new layers are invented. So physical and data link layer was combined and they are named as host to network layer. Then the network layer name changed to the internet layer, and the transport layer remains same, and the 3 layers are merged and the name given was the application layer. So this is the TCP IP model which was implemented first. So this is the first model which is implemented, and it is having the 4 layers. The first layer is host to network, second layer is internet layer, third layer is the transport layer, and fourth layer is the application layer. Then afterward we have seen that there are many things which was added, just like on the network layer we was having the IP, which is internet protocol, which is having the 4 further protocols. One is ICMP, IGMP, ARP, and RARP. Similarly, on the transport layer, there are protocols like TCP, UDP, and sctp. Then afterward, on the application layer, many protocols are there like smtp, ftp, http, DNS, snmp, telnet, and many more. So this is the diagram of the TCP IP model, and if somebody asks us what is the difference between OSI and TCP, the same diagram can be made, because this diagram is showing the clear-cut representation between the OSI and the TCP IP model. So this diagram also shows the comparison between OSI and TCP. Now we are going to discuss all the detailed diagram of TCP IP, means we are discussing all the elements of TCP IP. So first of all, we are discussing the IP. This IP we are taking from the internet layer. Now, IP stands for Internet Protocol. The abbreviation or the short form is the IP. Well, everybody is aware that we are having the IP address. Every system, every mobile is having the IP address, and that IP address, which is IPv4, IPv6, is taken from this IP protocol, Internet Protocol. But we know one more thing, that it is very unreliable. Unreliable means you cannot trust the IP. That's why we can say that it is the unreliable. It is not like that I am using the IP and you cannot trust me, because I have my partners also. The partners are ARP, RARP, ICMP, and IGMP. But if we talk about the IP, it is the unreliable and connectionless. So no connection is required for transmitting the data with the help of the IP. Then also it is the best effort delivery. Well, that is interesting. Well, there are two type of person. One is very particular in the task, means if you are giving the person a task, it will take out the proper way. But IP work with the best effort delivery. Whatever the task you give, it just give to other person and they do the task. So best option, it take out the best option. That's why it need the subordinator. You will see that every line of IP will promote the IP to have the subordinator. Now, why it is best effort delivery? Because in terms of technical terms, if I say, it do not check any error and it do not track where my data is. So no error checking or tracking. Whatever the error is there or coming or not, the IP is not bothered about it. It is only for transmitting. You give the data, it will send. That's it. Means the packet loss or not, that is not the part of IP. Their subordinate will see. Then afterward, one more thing which is important. The data inside the IP which we are sending, they are called the datagram. Just like we are having bits, packets, similarly here we are having the datagram. So here we transport data in packets, and those packets are called datagram. So these are the few things about the IP. And one more thing, that it is host to host protocol. Host, we know that from my system to your system, it is going to send the data. So it is host to host protocol. Now, we know that IP is going to provide the transmission function, and IP is unreliable, connectionless. So who is going to help? Yes, there are 4 elements of the IP which are going to help, and these 4 elements are ICMP, IGMP, ARP and RARP. So we can say that it is having 4 supporting protocol. And those 4 supporting protocol, first one is the ARP, Address Resolution Protocol, RARP, Reverse Address Resolution Protocol, then ICMP, that is Internet Control Message Protocol, then the next one is IGMP, Internet Group Message Protocols. And now we are discussing all these protocols one by one. So IP is the best effort delivery. Best effort delivery means it is going to take out the packet without doing any error checking or without tracking. So because of that, IP is having their subordinates. Subordinates or the helper protocol. So the first helper protocol for the IP is ARP. And that ARP stands for Address Resolution Protocol. Now, to understand this address resolution protocol, we must know that there are 2 things. One is logical address and one is the physical address. Well, we know that we are having a LAN card. Well, on the LAN card, there is some address which is imprinted, which is written. That is called your physical address. So that physical address is also called the different name like station address or the MAC address. So these are the other names of the physical address. And there is one more address which we know, that is called the logical address. We know that IP address, just like we are having 192.168.1.1, that is IP address, or it is also called the INET address, or you can say that it is the internet address. Both are the same thing. So we can mention that it is the internet address. Now, these 2 addresses are very much important. When you are going to open your system, the LAN card is there. LAN card is a device which provides the connectivity, network connectivity. So there one address is imprinted, means written. That is called physical address, station address or MAC address. But while communication, we use the logical address, means the IP address. IP address is not written anywhere. It is logical. That's why we say it is the logical address. Physical address is written somewhere. That's why we can see it. That's why we are saying it is the physical address. So what is the purpose of ARP? Whenever the internet address is given and we are converting to the physical address, there ARP comes into picture. So let us suppose that you are having the logical address. Means, say example, somebody gives you the IP, that this is my IP, means this is the logical address somebody gives you. And from that address, you can calculate or find the physical address. That is the purpose of ARP. That's why the name is given, address resolution protocol. Finding the address. Which address we are finding? We are finding the physical address. If somebody give you logical address, it is going to give you the physical address. So next subordinate or the helper of IP is the RARP. Well, RARP, as the name signifies, it is the reverse ARP, or we can say that reverse address resolution protocol. Well, the thing is very much clear to you. If something is the reverse of ARP, what ARP is doing? You are giving ARP logical address, ARP is returning you physical address. Reverse of that means you are giving somebody physical address, they will calculate the logical address. So that is the purpose of RARP. So here we can say that we are giving the physical address, means you are giving the written address, and they will give you the logical address, means they will return you the IP address. So both protocols are present with the IP. Means anyhow you are having any of the address that will be calculated. You have the logical address, use the ARP to convert to physical. You are having the physical address, use the RARP to convert to the logical. So that is the use for the ARP and RARP. Now, next we are having is the ICMP. ICMP stands for Internet Control Message Protocol. Well, controlling the message. Internet Control Message Protocol. Controlling means finding the errors. What are the problems? Basically, it is used by the host and gateway. So if somebody asks you where we are going to use the ICMP, so the hosts and gateway use it. So it is used by host, means the system, and gateway. We know that gateway is used whenever we want the security. So there we use it. And it is used to send the notification of datagram problem back to the sender. So if any problem is there, then it is going to notify to the sender. And one more thing, ICMP send query and error reporting messages. So it send query and error messages. Means if any kind of query is there in between the transmission or any problem occur, so that report is given back to the sender. One good thing is that it is going to send to the sender. Means if I am sending you some of the data and any problem exists in between before reaching you, so that will be informed to me that such type of problem I am facing. So that is report to the sender. So notification of problem given to the sender. So we can say that problem information sent to sender, means who is going to send, they will get all the information. That is all about the Internet Control Message Protocol, ICMP. The next one we are having is the IGMP. Well, IGMP, it is Internet Group Message Protocol. Well, as the name signify, whenever we are having group communication, just like one sender is there and there are multiple receiver, like I am just giving you some information, you are many people, you are getting that information. So for that we are having the protocol, that is IGMP, Internet Group. See, it is very good thing that with the name we can signify the control. ICMP, Internet Control Message Protocol. Control means controlling, finding the error, controlling all. Group means the group communication. So there is nothing to cram. It is very easy to learn. That Internet Group Message Protocol, it is for the sending group messages. So we can say that it is transmission of message to group of recipients. Means if there are multiple people who want to get the message, then we use the protocol, that is IGMP. So the network layer IP is having all these four protocols: ARP, RARP, ICMP and the IGMP. Now we are learning the transport layer protocols, which are TCP, UDP and sctp. So talking about the first protocol which is on the transport layer we are having is the TCP. Well, TCP stands for Transmission Control Protocol. Well, as the name signified, is going to help in the transmission, controlling the transmission. What is something different over here? Well, we have heard about the wired connection and the wireless connection. So you can assume that TCP is like the wired connection. So all the wired connection features are there with the TCP. So we can write here it is the connection oriented. Connection oriented means the connection is required, just like the wired connection, a connection is required, a wire is there, so that a connection is required. We can say that it is a connection oriented. Well, all the features of TCP you can assume from the wire. Let us suppose that we are having two systems and they are connected via wire, so connection oriented is there. Second thing, if through the wire you are sending some data, it is for sure guaranteed the data will go, because on the wireless we don't know data is going or not, but in the wired it is guaranteed. So we are saying data delivery guaranteed. It means that data will for sure go. Now one more thing, that it is the totally reliable. Reliable in terms that if I am connecting my computer from your with the Ethernet cable, totally reliable mode. So there is no problem. So it is totally reliable. We can rely on it without any problem. Then afterward, we can say one more thing. TCP is going to divide the data into small units called segment. So there it divide stream of data. If stream of data is coming into smaller units called segment. So here we are going to divide the stream of data into the small unit, and that is called the segment. And yes, the serial numbers are also given to those segments for the reordering purpose. Let us suppose that we are having very huge data and you want to send through the TCP. So the small division will be there. Let us suppose that this is the data. We can say this is the stream of data which is coming to the TCP. So TCP is going to put into small segments, and it will give the number also. So 1, 2, so that while they are sending, they can be reordered. Just like in the video file, if the video is transmitted, obviously it should be in sequence. You cannot say na the first song is coming, then the ending of video is coming, and then in between. No, there is a sequence of a movie, so that sequence should be followed. So while doing with the TCP, that is divided into smaller segments. And yes, so this is all about the TCP, Transmission Control Protocol, and now we are learning the UDP. Well, talking about the UDP, it is User Datagram Protocol. Now here, one good thing is that we can take out the example of the wireless communication. So if I say that your computer and my computer are connected via the wireless media, so it is using the UDP. So the first thing we will write, it is not connection oriented, it is the connectionless. So it is connectionless because there is no wire used. Well, second thing, if on the Wi-Fi I am sending the data, it is not guaranteed. The signals are coming at the other side. So data delivery not guaranteed. Means data is reaching or not, that is not guaranteed here. Then second thing is that it is not reliable. It is totally opposite of the TCP. So it is not reliable. We cannot rely on it. If you are putting a wireless media, so we cannot say that it is totally reliable. No. Now talking about the transmission and the communication, it add port address, means from which port the data will go. So it add the port address. Then checksum. Checksum is one of the error correction mechanism. Checksum. Let us suppose that I am transferring the 5 bits. So there is one more checksum is taken that these 5 bits are there. And if that 5 bits are reaching exactly, so that is matched with the checksum. You assume that there is a key or a code, right? That is also sent with the data. So if the data is reached correctly, we can check out from that code. Okay. So that checksum error control is also sent because it is a wireless transmission. So obviously it is using the checksum. So checksum error control and length information of data means how much the length of data we are passing. So length information of data. So these three things are also added with the data. So talking about the mainly TCP and UDP, TCP is wired, UDP is wireless, we are assuming. TCP is connection oriented, UDP is connectionless. TCP is reliable, UDP is not reliable. TCP, the data delivery is guaranteed. In UDP, data delivery is not guaranteed. In the TCP, a big stream of data divided into small segments, then sent. In the UDP, while we are sending the data, we use the port number, which port number, port address, checksum, and the information of length of data. So these three things are also added. Now we are learning the next protocol, that is sctp. So the next one is sctp, which is stream control transmission protocol. Well, talking about the stream control transmission protocol, it is the combination of TCP and UDP best features. We know that in the TCP there are few features which are good, just like we are having reliable data delivery guaranteed. In UDP we are having best feature is connectionless, no connection is required. So such type of best features of TCP and UDP are added and they are named as stream control transfer protocol. So we can say that combine best features of TCP and UDP. So TCP and UDP both best features are taken and given to the name as sctp. And one more thing, it provides support for the newer application, just like VoIP. We know that voice over internet protocol, VoIP, that is very much popular today. Just like on the WhatsApp calling we are doing, right? That is the example of VoIP. Today we are having Wi-Fi calling. In the many phones we just put on the Wi-Fi calling button. Then if you are connected to the internet, you don't need the signals. With the help of the Wi-Fi, your calling is done. So your WhatsApp call is VoIP. Wi-Fi call is the VoIP. So that is voice over internet protocol. So these are the examples of the SCTP, Stream Control Transfer Protocol, which combine the best feature of TCP and UDP. Now we are learning the application layer. Application layer of TCP IP is same as the OSI model. Similarly, the physical layer of TCP IP is same as the OSI model. But yes, there are few protocols we are learning, just like there is SMTP. So talking about SMTP, it is Simple Mail Transfer Protocol. Well, as the name signify, it is going to send the mail simply. Whatever the Gmail, Outlook you are using for sending the mails, for that the protocol help is the SMTP. The next protocol which we are having in the application layer is FTP, which is called the File Transfer Protocol. Whenever you are sending a file from one system to another, then it is used the FTP, File Transfer Protocol. So any file which you are sending, that is with the help of FTP. Then the next one we are having is the HTTP. It is Hypertext Transfer Protocol. Whenever you are opening some website, then they say HTTP, and then afterward they say www.facebook.com. So such type of websites are open with the help of the HTTP. Sometimes we are having HTTPS also. That is HTTP means Hypertext Trust Protocol secured. Means there is a secured line for opening the user ID and password. Just like you are opening some bank website, then while entering user ID and password, it convert to HTTPS. The next one we are having is the DNS, that is domain name system. Whenever you are opening some URL, just like you are entering www.google.com, actually that is the understandable English, www.google.com. System don't understand. So it is converted to some IP address. Let us assuming some IP address 192.168.1.1, assuming some address. So this is converted to IP address. Now this IP open and show you the result. So that result which is coming back to you again over here. So converting from URL to IP and IP again back to the URL. So that is called the domain name system. So DNS is going to help in that domain name system. The next one we are having is the snmp, that is simple network management protocol. Well, as the name signified, is going to manage the network. Means simply collecting the information of what are the devices which are attached, are they working properly or not. So that complete device management or the network management is done with the help of simple network management protocol. Next protocol which we are having is the telnet, and telnet is called the terminal network. Well, that is used for the remote login. Let us suppose that you are working from the home, and let us suppose that you are having some of the server of your company. So that server will be open on your system with the help of telnet. So telnet helps you to open the system of your office at your home. So this is also called the remote login, just like we are having the TeamViewer software, AnyDesk software. So these are the softwares helping us for a remote login. So that is the complete TCP IP model which was developed first. So this was the first model which was developed, TCP IP model. So this is all about the TCP IP model.